SSH stands for Secure Shell. And basically, on many platforms like Linux, OS X, even on Windows, you need to remotely connect to other machines, and you usually do that through a terminal. And basically, Secure Shell is that terminal. Some of the stuff I'm going to go through kind of quick, and then the more interesting parts and applications on what to use SSH for, I'll go over in more detail. But basically, SSH is replacing the old school R tools like rlogin, rshell, rcp. No one uses those anymore because they weren't secure. Then SSH1 happened. To make a long story short, it wasn't secure. So then they came out with SSH2, and that's what we use today. When you log into a computer, like let's say, how many of you are actually SSH'd into like P2, or how many of you have like an account on the Prime Lab, or have been on those bin machines or the Solaris machines? Okay, cool, yeah. So you can actually SSH into all those machines from home or from here, from anywhere. How many of you knew that? Okay, good, good. And so when you log in, you probably will use, most of you probably use, you type in your username and then you type in a password. That's called interactive login. Has anyone used, created public keys on P2 to log in without typing in the password? Yeah, okay, there you go. We're going to talk a little bit about keys and how it'll save time. Basically, you can log in without ever having to type a password. And then the host-based method is used less frequently, but basically you just put an IP address in a file, and then whenever that IP address tries to log into the machine, it accepts it and lets you in. So this one is pretty typical of when you guys log in. You type in your username, ask for your password, and then if you type it in right, it'll let you log in. And then at that point, you're in your terminal. And once you're inside of your terminal, you can either run like C shell or bash or all those other shell environments. I prefer bash. Does anyone else use like any other shells that anyone knows of? There's like bash, T shell, C shell. Yeah, bash is pretty common. So I've put these slides on my web server, and so if you want to download these slides and get them, you can look at them, and then this will tell you the exact files and paths and stuff. Some of this stuff I'll just go over kind of quick, but it's in the slides and you can download it. These are the files that you modify if you want to have a host-based login. We'll just go through some of this stuff kind of quickly. Hey Jim, this guy over here just walked in. That's Jim. He knows more about SSH than anyone else in here.
I do?
Yeah. Yeah.
Cool.
Yeah.
Hi, Jim.
Hi.
Here, right here, this is for Windows when you have a key for your key logins. This is what happens when you try to log in using a key. You just have your username specified, and then because you already have your key loaded on your host system, it'll tell you that you've already imported the key, and you don't have to type the password. And that's very convenient if you need to SSH into like 20 different boxes 200 times a day. It'll just automatically do it for you, and it's pretty convenient. So, in order to create a key, you're going to use this command right here. And remember, again, all you do once you logged in is you just run this command to generate a key, and that will create a key file. And all you have to do is copy that file into your home directory, and then basically you place there are two keys that get generated, a public key and a private key. You put the public key in your SSH folder in your home directory, and then you keep the private key with you, like on your laptop. And then whenever you log in, you just have the private key loaded on your laptop, and then you're going to use the public key, and what it does is it encrypts the public key will encrypt your messages, send it to the machine, and then I have a slide that I'll show you. That's what I'll do. Yes, this slide. Okay, so anyway, you have a public key and a private key. And the public key you can give to anyone. Basically, you can give those out, they're public. And the only key that you have to keep is the private key. Like, you'll keep this on your laptop. And so what happens is, you use the public key to encrypt a message. And basically, it just does a mathematical hash on it and generates some string of numbers. And then it sends this encrypted string of numbers across the internet. That's actually what goes across the wire. All right? And so then on machine B, the machine that you're logging into, it can use the private key to decrypt this number. Now, the private key is the only thing that can decrypt it. All right? So if someone is eavesdropping or capturing your packets, all they're going to ever see is this number. And it's actually a pretty cool property. And in one of our security classes, networking classes, we actually read the paper on how the algorithms actually work. But basically, you take large prime numbers and properties of exponents, and you can mathematically prove that this key is the only key that will be able to decrypt the message that is generated by the public key. And so that's basically all you need to know, that your private key is the only thing that can decrypt messages generated from your public key. And so, again, if you download the slides, this tells you exactly how to set it up. But basically, you just run that keygen program, which generates your key right there, and then you copy it into your .ssh authorized keys file, and then you'll be able to log in with using keys. Let's see, we'll go through some of this stuff. Basically, there are tools that you need to use if you want to have a whole bunch of keys. Some of these keys are called P-agent or Pageant, or who's heard of Pageant? It's like the putty tools. Who's heard of putty? Oh, good. Okay, yeah. Well, putty, putty actually comes with a set of tools. One of those tools is Pageant, and it's analogous to Keychain on OS X, or Keychain on Ubuntu, or whatever you use to load your keys. For those of you who don't know what I'm talking about, the Keychain is the program that just sits in the background on your operating system and makes sure that your private keys are loaded, so when you try to log in, that program will decrypt the messages for you. Does that make sense? Yeah, it just sits in the background, and whenever you do a login, it integrates itself and automatically types in the password for you using the keys. So we'll get to some of the good stuff here after some of this stuff. Another thing that's very good for SSH is X-forwarding. X-forwarding is basically remote desktop. So how many of you have ever used a remote desktop, like on Windows or OS X or Linux? Good. Yeah, that's good. One of the things that you have to do in your SSH, your config file, which is in your etc SSH, is you have to enable the excellent forwarding flag is equal to yes. And again, if you're not sure about all this stuff, a quick Google, you'll have step-by-step instructions on like 10,000 pages telling you exactly how to do it. But by and large, your default install will already have that set to yes, and your remote desktop will already work. You just need to give it the -y command when you try to SSH in. All right, now we're getting to a lot of the good stuff about why you actually want to use SSH for certain things. One of the nice features that SSH has for you is called a SOX proxy, and this is built in. How many of you have heard the word proxy before? Okay, good. Yeah, it's basically something that does something on your behalf. And, oh, look at that. Okay, yeah, so what are all the things you can do with a SOX proxy? Basically, how many of you have ever been like, who went to a high school who filtered what websites you could go to? Or, yeah, blocked stuff. Did your high schools, did they block Facebook? Yeah, of course, okay.
What's Facebook?
So there's that example. Another example is even if you are on OU's network and you are trying to like download research papers, if your IP address is from Ohio University, Ohio University has a deal with a lot of the publishers that let you download their papers for free. But if you are like at your apartment and you have Roadrunner or some other ISP, your IP address won't be in the OU subnet, and they won't let you download those papers. So that's kind of stuff like this, where what you need to do is have someone request all the websites you want to go to on your behalf, and then just send them back to you. Does that make sense? And so that's what a SOX proxy does. And so any machine, almost any machine that has an SSH daemon running, any machine that you can SSH into, nowadays probably is running a SOX proxy. All right, we're going to go through step by step on how you can set up a SOX proxy. And one of the things that's nice about this SOX proxy is you can just put the little exe. It's a standalone executable. You don't need to install it. You can just put it on a thumb drive. And then if you go into any computer lab anywhere and they filter what websites you can go to, you can just stick in the thumb drive and double click the exe, no installer, no admin rights, anything, whatever, and you'll be able to set up a SOX proxy to any one of your off-site servers. Since all of you are OU students, you can use the P2 machines. Just forward all your prom through them. All right. So I'm going to give a quick example here. Right now, if I open up, what's my IP? Here it is. All right. I just went to what'smyipaddress.com, or what'smyip.org, or whatever it is, and it says that I'm 35.20, which indeed is what my IP address is. I have a lot of adapters here. So here, yes, you can see, here's my IP address, here's my subnet, here's my default gateway. How many of you have taken the IRG class, the network admin class? If you guys get the chance, you should take it. What is it? CS
475, 575.
Yeah. And it's actually, you'll actually set up routers and configure firewalls, and you'll do a lot of this stuff. So you'll learn all about IP addresses and subnet masks and default routes. And it's very useful when you're trying to do this kind of stuff. So anyway, let's say that this wireless LAN is firewalled, and in some ways it actually is. It blocks certain traffic. But let's say that they're filtering what websites I want to go to, and I really want to go to a certain website. All right. And I have a Linux box sitting in my apartment. I live at Courtyard. And I want to set up a SOX proxy and tunnel all of my traffic through that SOX proxy and go to different websites. All right, so I'm going to do that right now. The first thing that I'm going to do is I will actually use the PuTTY tools to do this. And so if you go to PuTTY, this is the website here, I'll show you guys. The very first page that comes up is this one right here, and this has been the same for years. But you can just go to downloads, and here are all the EXEs for the PuTTY suite, and I've downloaded all of them to this folder right here. And there are slides that are going to cover this later, but for this one, we're just going to use this executable called plink. And that's the one that you need to have on your little thumb drive when you want to bypass firewalls and stuff like that. So I will just open up a command window. You don't need to have a command window open. What you could do is just write a bat file and then double click the bat file. And then the bat file will just call plink, the executable. And we're going to give certain parameters to it. All right? And I put in this capital D in there, and actually, no, let's do this. That's P2, right? Yeah. All right. So I think my username is. Hopefully this works. I haven't tried it on this machine. There it is. Okay, plink is, I'm basically now SSH into P2. But notice that I did that -D command. All right, and what that -D command does is it basically sets up, the actual command itself was -D 1650, right at the top. And so what it says is on my local machine, on my laptop, if this represents my laptop. And basically you have 1 to 6,500, 35, no, 36. 35 is the last valid port. You have all these port numbers. Your operating system has port numbers 1 through 65,535 or 36. These port numbers, who knows what port numbers are? A few people? Good. Okay, well, port numbers, how many have heard or seen stuff, you're trying to go to a website and you hear stuff about port 80 or you see a :80? All right, that's because HTTP traffic uses TCP port 80. All right, and basically all web traffic, except for the secure stuff, uses port 80. All right, and what I did with this -D was I told my laptop, hey, on port 1650, any packets that I send to myself on port 1650, here's P2, right here. Any packets that I dump into this port on my local host transparently get encrypted and sent encrypted across the internet to P2. And then from P2, they come out of the other end of the tunnel, because this is the tunnel. When we talk about tunneling, this is where the tunnel is. They come out of the tunnel, and then they go off to the rest of the internet. So basically, you create a tunnel on your laptop, and you say, hey, any packets or any information that I send into this hole right here magically come out on another computer. And so what the SOX5 proxy does, is you send in HTTP requests, like for your Facebook or for your what other website you want to go to. You send the requests in here, they pop out right here. This guy sends the actual request to the internet, to Facebook, to whatever, and then the web server replies back to this guy. This guy re-encrypts all the traffic, sends it through the tunnel, and it pops out back at your laptop. Does that make sense? Yeah, and so that's how that works. And so the other thing you're going to want on that thumb drive is the standalone version of Firefox, because you will need to set your internet or your web browser settings to do that. I'm going to show you how to do that. Okay, so basically the first step that I did was I did this -D command right here. And I set it up on port 1650. And now what I need to do is tell my browser that I want to use port 1650. All right? So I'm just going to do this again. Here we see what my IP address is. All right? Now, real quickly, if I ping p2.cs.ohio.edu, it's going to return to me the IP address of P2. Now, we can see here that P2 has an IP address of 1.12. All right? And from this website that I was just at, the IP address of my laptop right now is 35.20. So if I want to make a request to any web server, I don't want the web server to see 35.20. I want it to see the request coming from P2. Does that make sense? And so that's exactly what I'm going to do. And so all you really need to do is go into this Tools, Options, and then it is under Advanced. You go to the Network tab, and then in the Network tab you can configure the settings. And basically all you have to do is check this box that says Manual, and then you're going to type in your SOX host. All right, and what we're doing right now is we're telling Firefox, hey Firefox, I have this hole set right here on port 1650. And so you're just going to say, hey Firefox, all the web requests that I type in, all your requests to Facebook, to whatever, just dump it into this hole right here. They'll magically come out at the other end of the tunnel, and the requests will just get served that way. So what do I need to set this number to? Yes? Yes. All right, so I'm going to hit OK. And I'm going to hit OK. And now if all went well, look at that. I go to what's my IP address.org, and now it thinks that my IP address is P2. Everyone get that?
Got a question.
Yeah, question?
So I noticed in the SOX configuration, you kept the addresses as localhost.
Yes.
Well, why wouldn't you put in the IP address of like P2, for example?
Yeah, great question. Remember, I'm telling Firefox, forward all the packets to the entry point of the tunnel. Where is the entry point of the tunnel? Here's our tunnel right here. This is my laptop. This is my local host. The start point of my tunnel is my local host port 1650. And so you're telling Firefox where the beginning of your tunnel is.
Okay.
Firefox doesn't care where the end of your tunnel is. And that's sort of the beauty of the whole thing.
And you might see some anonymous proxies online. You actually enter their web address. But if you aren't going over SSH to get there, then none of your traffic is being encrypted between that link. You know, so that's one thing to be careful about with those anonymous proxies. Yeah.
And the other really good thing about this tunnel is all the traffic sent between here is encrypted. Okay, so if there's a firewall here, if you're in China and the government is tracking you, and they're monitoring every site you go to get every password that they can get out of you or whatever, this whole tunnel is encrypted. They can't get that information. Aside from some very sophisticated attacks and like man-in-the-middle hijacking and stuff that you would go to a security conference and write a paper on, no one's going to be reading these packets, because they're encrypted. All right, so you're safe. And if someone does read them, they're breaking a couple major laws. I'm pretty sure about that. So, but yeah, good question. All right, so now we can see that my IP address is 1.12. So to the rest of the internet, I am P2. All right, now that sort of has some pretty big implications. So like, let's say, later on we're going to get to some more examples, but when you look like somebody else to the rest of the internet, you can do things and people think it's someone else doing them, not you.
Steam.
So the only caveat, though, is you need to have an account right here and be able to SSH into that guy. All right, so let's go back to the slides.
How does one get an account on P2?
All of you should have an account.
At least the CS people.
The
I don't know
CS.
if the EEs do or not.
Yeah.
The Prime Lab 307 or
Even
Are you
the
taking
new
a
labs
CS
on
class
the
this
first
quarter?
off.
if you register for
No.
at least 1 hour of the CS class, you should automatically get an account.
Yeah.
For that year.
Very possibly.
Yes, and if they do delete your account, what you do is at your own apartment, you have your own Linux box.
Well, Courtyard has the advantage of being on the OU network. Not some other places don't necessarily.
That's true.
Well, something
Yeah,
you
where I'm
can
having
try.
kind of horrible now.
There used to be a machine called ACE, and I think every OU student gets their own account on that
Yeah, the
particular
Oak,
box.
yes, the Oak ID, currently, the Oak system's being decommissioned, but currently, anyone with an Oak ID has an account on ACE, so you could use that.
I think it's ace.cs.iu.edu or something, right?
Yeah.
Or maybe ENT, I'm not sure.
I think it's ace.cs.edu. But
I
I don't think it's been updated with the stuff for a long time.
Well, it's got SSH that,
Yeah.
That's all you
Yeah,
need.
proxy should
all
be good.
all you need
Yeah.
for port
Last
40.
time I tried, I could still connect to it, so.
Yeah.
Yeah, but you've been a student here for a while.
Yeah, I mean, honestly, you could take a crappy laptop and put it above a ceiling tile in some room and leave it on, and it'll have an OU IP address, and you could just use that whenever you want. I'm serious, it would work. You just have to make sure you occasionally send out pings or keep alive packets so you don't time out with the wireless. But you didn't hear this from me, and that's not recording. Okay, so basically, this slide shows exactly what I just did, except I used P2 instead of my home box. Another thing is, who's heard of dynamic DNS, 9DNS? Okay, it's a very, very nice tool. It's free, you can just sign up for an account, and who knows what a DNS server is? I know all you guys do, but like for you guys too, a DNS server is a domain name service, and what it does is it maps strings to IP addresses, like www.facebook.com resolves to an IP address or a block of IP addresses. And in order for you to actually send the actual IP address, you need to resolve it to the actual IP address. And what DynDNS basically does is it's a little program. It's this one right here. It runs in the background, and whenever you connect to a new wireless network and get a new IP address, it'll go out, contact the DynDNS DNS servers, and say, hey, here's my new IP address. So then if you try to ping it, the DNS server will return the current IP address of your current machine. And that's very handy because if you have like dial-up or like cable or whatever, and your IP address changes like 5 or 10 times a day because your connection goes down all the time, Dying DNS will automatically reconnect you and keep your IP address up to date. So if you have a server sitting at home with some important files, and you get to class and realize that, oh crap, I left my report on my computer at home, you can SSH in or SFTP to your computer. But if you have a crappy ISP and your IP changes 10 times a day, you won't know what the IP address is. So that's why you use Dying DNS, and then you just always use your host name, your DNS name. Yeah?
What happens if you have multiple adapters, like a wireless and then 2 Ethernet ports, for example? Like, which one will it resolve? Will it give you all 3, allow you to connect through all 3, or will it just pick one?
Yes, that's a good question. The answer will come basically operating system specific, but basically the main adapter will be the one that can reach the internet. All right, so if you are logged in, if you have 2 wired adapters in a wireless internet, and you don't have anything plugged into the wireless, or to the wired, obviously it's not going to use those. If you are connected to a wireless network, for example, OU, but you're not logged in yet, so it's just not forwarding any of your packets, and it can't connect to the internet, then you just can't connect to the internet. But if you have a wired one, your operating system, I think Windows will do this, I think OS X and Ubuntu will also do it, your main OS will favor a wired connection over a wireless connection because you'll have more bandwidth. And so it'll just use whatever your highest priority adapter is that has internet access.
Okay.
OS 10 does that.
Just to clarify that, on OS 10 at least you can actually manually set the priority.
Oh, okay. Yeah.
And then that also counts FireWire and Bluetooth.
Oh, okay.
Yeah, and it's like, I always, like, manually disable all but the main one. Like, I've had laptops at LAN parties just randomly in the middle of a game decide to stop using the wired connection and for some reason switch over to wirelessly connect or something.
Yeah,
and it just
that's
kills.
annoying.
So I tend to disable all but one if there's multiple.
Yeah. Okay, so basically here's some of the other benefits that it'll give you. You'll be able to, another really cool thing. Let's say you go to Donkey or you go to Perks or you're at the front room or you were at the talk 2 hours ago at 5 p.m. They probably said this exact same thing. But everything that you send out over the wireless is, for the most part, not encrypted, and anyone sitting next to you can read all of your stuff. If you're sending emails, if you're doing chat, if you're making posts on Facebook, whatever, the person next to you can read all that. All they have to do is run a sniffer program. For example, a program called Wireshark is a good program to capture packets from other people. But anyway, if you encrypt it and you do a wire capture, all you see are a whole bunch of encrypted messages. You can't read it, it's just encrypted. So you don't know what's going on. All you know is that traffic exists and it's going through the air. That's all you know. You can know if there's a little bit of it or a lot of it, but that's basically it. And so, yes, this is the big one I wanted to mention. The O'Reilly website that has a whole bunch of books online, if you have an OUIP address, you can get a lot of those books or articles and read those, as well as some of these other papers. And if you go to grad school, the papers and stuff will become much more important to you. Another thing is, if you're at work doing whatever job it is, your employer is probably monitoring everything you do. They're probably monitoring all the websites you go to and have weekly reports to management on who spends the most time on what websites. Has anyone ever gotten in trouble for that kind of stuff? Really? Okay, either way. Well, if you encrypt it, they won't know. So you can do that and then just send stuff to your apartment and forward it through there. Yeah, John?
A lot of times the way it works now is people will have just a web filter and they'll just block all the stuff. So you'll encounter like a watchdog demon at your gateway. They can keep track of who makes requests to where, but without permission to get out, it won't matter.
Okay, and that's another great reason to have a SOX 5 proxy. Just install Linux proxy at your apartment, your employer blocks your website, you just tunnel through the firewall, and now you can go to whatever website you want to. Basically, if you can form an SSH connection from a computer to any other computer, you can get to whatever website you want to, that the computer on the other side of the firewall can get to, you can get to. Yeah.
DynDNS is typically blocked in most web filters, so you have to have a manual IP address built in.
How does it distinguish between
It knows
DNS and other DNSs?
the URL you're using.
Oh, it's
Yeah, because you're going
CX,
you're going to have to use DynDNS lookup.
Well, DNS should talk to the other DNSs.
Yeah.
They should.
But your
It doesn't block the DNS,
URL
it
has a
literally just
specific
blocks URL.
format as to where
Yes,
you're at.
yeah. Like
So-
.ats.cx, they could block all of those in the host file.
Yes, but ironically, .ath.cx is the domain name for the Virgin Islands. They just sold it to DynDNS.
Yeah,
So
but I mean, they could still choose to block all.
they could choose to block those. I'm not
Because
sure.
there's actually a checkbox for proxies.
Okay, I'm not
for-
sure if
and
that
I'm
would,
sure-
if you went to like DOS and just tried to ping that IP address, it would be an ICMP echo request, which wouldn't go through a web filter, and so you could just get the IP address that way, perhaps. They'd have to be doing more sophisticated stuff.
The web filters are pretty sophisticated. I've been shocked.
I'm also
really.
curious.
If they're doing that, the last thing you can do is just have DynDNS send you a text message to your phone with the new IP address every time it changes.
And then they can't do anything with that.
Is this at your workplace?
I've been behind a couple web filters. The best one, in my opinion, is iPrism. It's fucking ridiculous to get around. I was trying to read development blogs, and it wouldn't let me through.
Alright, now what I want to do here is talk about some more stuff you can do with tunneling. It's going to take this same example, it might twist your brain a little bit on what you're doing, but it'll let you do things like hijack web servers, or spoof somebody else, or all kinds of other stuff. And that's basically using these -L and -R commands. And basically, what you're doing is the exact same thing, except you're just sort of changing the behavior on what happens when you form these tunnels. So you can form tunnels between any two machines and send encrypted packets between them. All right, and by doing that in the right patterns, you can actually fool a lot of things into thinking things they shouldn't be thinking. We're just going to give some quick examples like that. Hopefully, we can get through.
I got a quick question.
Yeah.
Is it possible, so these tunnels, is it possible to do like a multi-hop, multi-tunnel?
Yes.
Bingo.
Yeah, it's possible. You can using the commands we're talking about now. You create a tunnel here, then create another tunnel to another machine here, and then create another tunnel to another machine here, and you just keep going and going and going. And that's actually one of the things that a lot of hackers try to do, because let's say they're hacking somewhere, maybe the Department of Homeland Security, and the Department of Homeland Security has logs that print all the IP addresses that try to access it. And let's say that you only do this hop one time. They'll trace the IP address to say, oh, P2 was trying to hack the Department of Homeland Security. Then they email Tisco, and Tisco says, oh, at the time the attack went on, these 12 users were logged into P2. And of those 12 users, this user has a log file with SSH connections going on. And then they probably got you pinned pretty quick. But if you play this game several degrees across several different networks, like let's say OU, some server in Turkey, back to, I don't know, some server in Akron or Columbus or whatever, and you just keep hopping around, you can only go so far.
Make sure you stop at the University of Miami.
There you
Yeah,
go.
and then basically whoever you want to get the most heat first, that's the place that you do your attack from. Or if you're doing, like, for example, a distributed denial of service attack, you're going to end with the place that has the most bandwidth, because then you can just flood their pipes and, you know, stuff like that.
Not that we encourage any of this.
Yeah, no, don't do this. This is all theoretical. Yeah, no.
Oh,
Yeah.
Knowledge is power.
Yeah. Yeah.
This is
All right,
purely
so-
academic.
Let's see here. Okay, well, I'll just real quickly mention this L command and the R command. What we did in the previous example was a SOX proxy. We forwarded HTTP traffic. Let's say you want to forward your World of Warcraft traffic, or your BitTorrent traffic, or whatever traffic is being blocked by whatever network you're on. You want to forward that to some network where it's not blocked. You can do that with this. And now I'll make the disclaimer that if you're going to do it with something like BitTorrent that uses thousands of ports and stuff, it could be a little more tedious. But we're just going to go through the simple example with like one port that you're going to be using. This -L command right here, it starts a daemon. By daemon, think of it as this hole right here. It starts a little machine or a little program running on your computer, listening on this port, and then anything that goes into this port comes out of this machine, sent to this host. All right, so if I was on my laptop and I sent a packet into my port here, it would come out of this machine, like let's say that was P2, and then it would go forward that to here. All right, now that's the exact same thing we just talked about with the SOX 5 proxy, except this is replaced with, you know, port 1650, and this was P2, and then this was 80, like to what's my IP address.org, port 80. All right, that's all that did. The R is the exact reverse of that. The -L stands for local, the -R stands for remote. All right, we're going to go through some examples. The first example is using this program called rsync. Who's used rsync before? A few people. It's basically a way to back up stuff on Unix or Linux. And in this example, we have your local host, which is like your laptop, and you're on a bad network that has a firewall here that blocks all rsync traffic. And so what we do is we set up a tunnel, and all the packets that we send in to port 873 on our local host get tunneled through the tunnel, and they come out at P1, and then they get forwarded to rsync.gen2.org, port 783. This is the exact same thing you can do with World of Warcraft. Whatever port World of Warcraft uses, replace 870 or this port with the port that World of Warcraft uses, and this with whatever server it is. And then you'll be able to send your WoW traffic encrypted to whatever network that, like for example, P2 would work, or P1 would work. So you can do that. A more interesting example, this one goes back to hijacking that web server that I was talking about. And this uses the -R command, which is the remote tunnel. And so basically what you're doing is, let's say that we have this web server here, and it's called steve.cs.ohio.edu. And it was actually, well, John knows about it too. Yeah. And so basically, this hosts a website, but we have SSH accounts on it. And so one of the things that you can do is when you create these tunnels, every example we've done so far says, I'm going to make a local hole here, and anything I shove into here comes out here. What we're doing with the -R command is we're opening the hole here on this remote machine, and we're saying anything that comes into this hole here, send it through the tunnel and have it come out here. All right, so what does a web server do? It listens on port 80, and it serves requests. Whenever a request comes in, it answers it and sends it back. So if we have a web server running, but we set up the remote port to say, hey, whenever you get HTTP traffic, don't actually send it to the Apache web server. Send it through the tunnel to this other server I have over here, and let that handle all the requests. Does that make sense? All right, so that's exactly what we have here in this example. So here is our steam.cs server, and here is another server that serves questionable content. But normal people don't know anything about this computer at all. All they want to do is go to steam.cs.ohio.edu. And in this example, we chose 8080, but you could just as easily use 80. So as a normal user, you type in your Firefox or Chrome or whatever, you go here, you hit enter, you wait for the request to load. What happens, your request comes from the internet to this machine, and instead of being handled by Apache, it goes through this tunnel, and then this machine, let's say this machine is running a web server. Now this web server doesn't even need to be running on port 80. This could be running on some oblivious port like, 25,000. And all it does then is it receives the request, and then it returns whatever images or content it wants back to this guy, and then it returns it to whoever the browser was who went to it. So let's say that for some crazy reason you got, I don't know, root access on like CNN's firewall. You could redirect all their traffic or whatever to some other box. Now you'd probably need a lot of boxes and a lot of bandwidth to do that for a big profile site like that. But a lot of smaller sites, you'd probably be fine doing whatever. Does anyone have any questions, or does this make sense to everybody? And again, the slides are going to be online, so you can play with this with your own servers that you have permission to be using and not try it on anyone else's. That'd be wrong, unethical, whatnot.
I'm gonna
Any
pause.
questions?
He's got
Yeah, we're good.
We're good.
Oh, cool. All right. So that's that example. Yeah, this is a nice reminder. Remember, you're tunneling forwards traffic through intermediate links. So if you're going to facebook.com, which is right here, from your laptop, and you're tunneling it, it's going through this tunnel. If this tunnel is a 5600 baud dial-up, it will be slow. So whenever you're doing tunneling, whatever pipe in between any of your tunnels is the smallest, that will be your maximum bandwidth that you'll be able to use. All right, so in this hacking example where you jump around 12 different times and you go around the globe 13 times, when you're SSH'd into that 13th node, you're going to have a lot of latency because your packet has to go here, bounce to here, bounce to here, bounce to here, bounces around the world like, however many times before it actually lands at its destination. You'll have more latency, so typing on keyboard might be annoying.
But file transfers, on the other hand, probably won't.
Yes, file transfers, if you have sufficient bandwidth, will still be fast. It's just that it'll take the first 1 second for the beginning of the file to get there, but once it gets there, the rest of the file is still coming. All right. Other quick examples. No one really uses POP3 anymore unless they're the old people. Everyone nowadays basically uses IMAP or whatever. But you can secure your POP3 accounts. You can secure basically any application you can think of. Let's say it's not encrypted, you can encrypt it. FTP is another example. Is that the pizza guy? Yeah.
Awesome dinner.
Oh, I didn't say. Good, yeah, yeah. By the way, don't use POP, use IMAP. Yeah. So basically, any application, let's say you write an application for your own Java class, you could encrypt it through SSH. Yeah. Okay, this is the last part we're going to get to. And this is other cool stuff you can do with SSH for like file transfers and all kinds of stuff like that. When you SSH into a machine, like for example, in order to SSH into a machine, you just say sshp1.cs.ohio.edu. What you can do is after that, put a space and then quote, and then a set of commands that you want to have executed upon your login. Now, that being able to do that is actually quite useful, and we're going to go through some quick examples. But for example, right here, this one will take a CD-ROM, it'll cat, dev CD-ROM is your CD-ROM drive, so if you have a CD in there, and you cat dev CD-ROM, it will cat out all the bytes on the CD-ROM drive. If you pipe that, who knows what a pipe is? Yeah? When you guys take operating systems, you'll know what a pipe is. But basically, it just says, take the output of this program and set it as the input to this program. That's all a pipe is. It'll pipe it into the SSH program, and as soon as it gets to the SSH program, you will SSH into P1, and then you will, the first command that you give it is cat, whatever standard in is, redirect it to my local, well, to your file.iso. All right? So, real quick, anyone on this side of the room, aside from Jim, does anyone want to, or over here if you're not the people you know what I'm talking about. Who wants to say what this command does? There. Yeah.
That would remotely rip the disk, wouldn't it? Byte for byte?
Yep. Yeah. What you've done is you just made an ISO of whatever CD-ROM is in your local CD-ROM drive, sent it over the internet to P1, and you dumped it as an ISO on your directory. And so that's what that command does. All right. Let's see here. I will be done. I'll try to hurry this up within 10 minutes, and then we'll eat pizza. This is also another really cool tool. It's called Screen, and there will be probably an ACM talk just on Screen. And Screen is this program that basically lets you preserve your SSH session between disconnects. So let's say that you log into a machine and you start doing an update, and you realize, oh, this update will take 5 hours to complete, but you have to leave now, and you're on your laptop, and you have to close your laptop. And when you close your laptop, you lose your internet connection, and when you lose your internet connection, your SSH tunnel closes, and when that happens, your SSH connection dies. So your update halts, and so you can't finish the update. But let's say you want the update to continue running after you disconnect from the machine. That's what Screen does. There will be a talk about it probably later. And the slides are here too, so they'll tell you how to do all that kind of stuff. Right here's another one. This one line will back up your whole hard drive, send it over the internet, and put it in a bzip2 file.
That's going to take a bit.
It could take a little while, but that's what it'll do.
Especially for you.
Funny trick. I hate it when speakers give talks and they have stupid commands like this and they think they're so cool, but they don't listen to caveats. If you have a folder that is like, let's say, A and then B, and you symlink them circularly, just for whatever reason, and you copy A, which says copy B, which copy A, and you get stuff like this, that command might not work very well. So, yes, theoretically it'll back up your hard drive. In reality, you're going to want to be more careful than that. So here are the putty tools. I went over these, and P-Link is the one that I used right here to connect into P2. What's nice about the putty tools is they don't need any installer and they'll all run on Windows. OS X and Linux have the equivalents of all these tools basically already built in, since both of them are Unix derivatives. Cygwin is, who's here has heard of Cygwin? Okay, cool. Cygwin, I like Cygwin. I have it installed on my laptop. It basically lets you run a Linux-like environment on your laptop. And it gives you all of the shell commands and all the SSH properties and everything that you expect. And it'll run on Windows. And so I have a Windows box right here. I can actually SSH into this box. And that's what my last demo is going to show. I can actually SSH into this box remotely. And using Dying DNS, it's actually pretty cool. So if I have my laptop and I end up back at my apartment with my laptop still on, I can take remote desktop of this laptop, and I don't even need to know what the IP address is because I have Dying DNS running. The very last thing I want to talk about, before the other very last thing I want to talk about, is what you should do or how to set up your own LAN at your apartment or whatever. A very useful thing to have at the gateway of your apartment is a Linux firewall, Linux box. A lot of people have those little like D-Links or whatever wireless routers. Those are okay if you're not cool. But if you are cool, you're going to get one of these, and you'll be able to do all kinds of stuff. And what you want to use to do all kinds of stuff is this thing called IP tables. It basically lets you turn your Linux box into a really, really, really pimp router.
You want to talk about IP tables next quarter?
Maybe.
Okay.
Maybe. There is a learning curve to IP tables, but you can do some really, really, really cool firewall stuff with IP tables. Basically, I have at my apartment several computers behind my firewall, but I can choose to SSH into like Nykl.ath.cx, and depending on which port I choose to SSH into, I will either SSH into this computer, this computer, this computer, or this computer, all using the exact same host name, just changing the port. I can do the exact same thing with SFTP and file transfers. I can copy files remotely from this computer to this computer, quote, 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 same thing, or to this one, just using different ports. Yeah, question?
Is that something that you do in your router's port forwarding or in the
Yes.
DNS client?
In the router's port forwarding, hence IP tables.
Okay,
Yes.
got it.
You're just gonna have a little script that sets your IP tables. You can do all your forwarding right in
No,
there.
my router can do it, yeah.
Yeah,
Do
question?
you need two Ethernet ports on the machine, or can you take like a PCI or PCIe wireless card, and then can you like do like an ad hoc network throughout the house to give yourself like pseudo wireless with that machine?
Yes, you can do that exact same thing. The reason why I said multi-home is because
It's
your
preference.
cable or your cable internet or your DSL or whatever will come in, and that will plug in at some point into one adapter.
Okay.
Whatever other adapter you have, it could be a wireless adapter, it could be a wired adapter that plugs into a wireless hub,
Okay.
it could be whatever. You can do that and set it all up.
But that one needs two ports in order to run for that, right?
You're going to want to use two. You could do it with one if you plug your input from your ISP into a hub, not a switch, a hub.
Okay.
Because it's stupid, it doesn't try to do frame forwarding, it just broadcasts. Yeah, on
all
hubs.
ports.
Yeah, and then that way, you plug this into that hub, it'll still be able to connect with it, and then you'll have your firewall set up, and you just use that interface.
Okay.
The problem with that is, like, let's say someone who's bad is inside your network, they could easily hijack your connection at that point. You probably don't really need to worry about that part. It's at your apartment. This next slide just reiterates the previous slide. DynDNS, it's free. There's a little program that runs DD client. Then you basically can do this to your DNS name, and then you have internet, whatever website you want to go to, where you are. Because you just set up a SOCKS5 proxy, tell Firefox to use it, and then you're just going through your local ISP at your apartment. Does everyone get that? Yeah? Cool. All right. This is the last thing we're going to show. This one is, I guess, in some way a little more esoteric, but it shows, it builds on that command that you can, what you can do on login with SSH. All right, and one of the things, who's heard of SCP? All right, SCP is short for SCP. Who's heard of CP before? Okay, CP is copy.
Multiple versions of CP.
Yeah, CP is copy. S is for secure copy. SCP uses the SSH protocol to transfer files, and it just uses SSH to copy it. It's the exact same for SFTP. Who's heard of FTP? Yes. Don't ever use FTP. It's a horrible protocol. It is not encrypted. The password is sent in clear text. And it has a weird paradigm where your server, the server has to send SYN packets, TCP SYN packets to you, as well as you sending SYN packets to it, which means any firewall in between any of those will probably break it. Don't use FTP. Use SFTP and SSH. The very last example I wanted to show is I have on which computer? This guy. This right here is a my router at my apartment. And in here, I have 650, let's see what that was. Well, basically I have 650 text files. These text files are source code for the engine that Chad was talking about earlier. We built a game engine, 3D game engine, does all kinds of cool stuff. We'll do a talk later. Yeah, it's a real game engine, does everything you think a game engine would do. But anyway, here's the source code for it, written in C++. And let's say that I want to copy all of these files from my router to my laptop. All right? Now, let me just double check here. There. Yeah. Okay, good. All right, my IP address on my laptop currently is, ironically, right before I was turning on my laptop, my DynDNS client messed up, and so the DynDNS on my laptop isn't reflecting my laptop, so I'm going to use my laptop's IP address instead of the DynDNS hostname, which is unfortunate because I want to use my DynDNS hostname, but it happens sometimes. If you use the pay subscription, it doesn't happen. All right, so I am 35.20. All right. Now, remember, this SSH command right here, this terminal, is on my at my apartment, and I want to copy files straight from there to this laptop. And I will do that. Where do I want to copy them to? I want to copy them to this folder, temp source. All right, right here. Here's a folder, temp source, and I want to put all the source files here, there. Now, one of the things that I can easily do is just use SCP. All right, and I'll do that one first. So I'm going to say SCP copy star, which is all the files in here, and I want to copy that to user at 132.35.20. And then so hopefully I typed it right. Yes. All right. Now I'm copying all those files. You just saw them appear down there. It's copying all 650 of them. It's sure taking a long time. Okay, it took like 12 seconds. What happened here, it showed every single file transfer. All right, it showed the rate at which it transferred. Now, one of the bad things with SCP is it makes one TCP connection for every file it transfers. All right? Now, that's not a problem if you're transferring like one or two big files, but when you have many, many small files, it just adds overhead. For every single file, you have to do a three-way handshake. Again, take the networking class, the IRG, you'll know exactly what I'm talking about and why that's slow. And so we're going to do it a more neat way to transfer all these files. Let me just delete them here real quick. And that's exactly what this slide is showing. Who's heard of tar? Tar balls or bzip, or who's heard of a zip file? Yeah, okay. We're going to use the tar command combined with SSH to transfer a whole bunch of files only over one TCP connection that's encrypted with SSH in one line. And that's given right here. I'm going to just do this one right here. And basically, you can either push files from one machine to another one or pull them. And the slides are up, but we're running out of time, so I'm just going to do this one real quick. So I'll just come right here. And basically, what tar I'm doing right here, I'm saying tar, create a file archive, and output it to standard out. All right? And do that on the current directory. All right? So if I just hit enter right here, it's going to just cat out, by cat I mean print to the screen, all the source code in all the files. So I hit enter. Here's all the source code. You're actually looking at over 100,000 lines of source code that went through there. I went pretty quick, actually. But that was all the source code for a whole engine. And so if you were sniffing it and it wasn't encrypted, you would now have a game engine that you can compile. But it was encrypted, so you can't. All right, so the very last thing that I was going to do now is everything that just got printed out to standard out, I want to pipe it. Remember, output it from this process to the input of this next process. I'm going to pipe it to SSH. All right, and what I'm going to do is SSH is going to connect to user at this laptop right here, which is
5.20.
35, yeah, 35.20. And now, what happens is, as soon as this machine logs in, it's going to execute this command, which is change your directory to sigdrive/c, which is just my C drive. When you install Sigwin, you guys just have to go to /sigwinc instead of C:, just small nuance, but no big deal. Slash, now I was going to put it to temp source. All right, and after I do that command, remember what I've done is I've taken all those lines of source code, piped them into SSH. Now that I've logged into SSH, I changed my directory, but I still have all that junk coming in. I need to deal with that junk. And in order to deal with that junk, that's what this very last command does. And that is tar, you're going to extract the file archive and put that to standard out. So right here, you're creating it with the -C. Here you're extracting it. All right, so it's just basically like that. And so I'm going to say tar extract. All right, now let me just double check, make sure I typed that right. One of the things you want to make sure is you type some of these commands right. Because when you're doing piping like this, you could just as easily wipe out your whole hard drive as get it right. Yeah, you have to make sure you get it right. But yep, so I think it looks good. Good. Let's see what happens.
Bring up your folder before you
Oh, yeah.
execute that.
So here's the folder. You hit it. Done. And you could see that that was way, 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 way faster than SCP because it was only one TCP connection. And so, again, these are just regular ASCII text file. I open it up. Okay, C++, we all know C++. And so finally, that takes us to the conclusion. Here's the summary. You can do all kinds of cool stuff with SSH. I'll put these slides online, make sure they're online, that you can get to them, and that concludes the talk on SSH. Any questions? Yeah.
What's that website where they're going to be put on?
Yeah, that's a good question.
Yeah.
I will determine that while you guys eat pizza and copy it there. And it'll be up on the projector before the pizza's gone. Thanks.
So, 5 pepperoni